This topic is about kinematics. Before we start, let's go through some key concepts and keywords that we'll be using in this topic. Firstly, displacement. Displacement is represented by the letter S and is defined as the change in position of an object with respect to a fixed point at a particular instant. It consists of both magnitude and direction. People often mix up displacement and distance and think that they are the same thing. But we need to note that displacement is not distance and distance is not displacement. I'll be elaborating on that with the examples later. So let's say we have the s-axis here with our fixed point O here. So if s is more than 0, our particle will be here. If s is equals to 0, it is at the fixed point. So here is where s equals to 0. And if s is less than 0, the particle will be in the negative s-axis, so the left side of our point 0, so about here. Then this is where s is less than 0. So let's convert displacement to distance. First example, when t equals to 0, s equals to 0. This just means that the particle starts off at our fixed point O. And then when t equals to 3, s equals to 5 meters. So this shows that our particle traveled in our positive s-axis direction, which is rightwards, and it traveled 5 meters. Therefore, our distance traveled is simply 5 meters. Next, when t equals to 0, s equals to 0. When t equals to 3, s equals to negative 6 meters. So this is where s is at t equals to 3. Since there's a negative in front, it shows that the particle traveled in the negative s-axis direction, which is leftwards of point O. Therefore, our distance traveled is simply 6 meters, because it traveled 6 meters in the negative s-axis direction. This is where you start seeing some differences between your displacement and your distance. Your displacement will have a negative sign in front because, as mentioned previously, it consists of both magnitude, which is your 6, and your direction, which is represented by the negative sign in front. However, since distance doesn't consider the direction, it is just 6 meters. Next, when t equals to 0, s equals to 4 meters. This means that the particle starts off 4 meters away from our fixed point O. Therefore, our particle starts off here, while our fixed point O is actually here. And then when t equals to 3, s equals to 9 meters. Note that this 9 meters is with respect to our fixed point O, because that's what displacement is. It's always with respect to our fixed point. Therefore, our 9 meters spans from our fixed point O all the way to this end here, where t equals to 3. Therefore, we can find our distance traveled, which is actually represented by this arrow, as 9 meters minus 4 meters, which is 5 meters. Therefore, please help me change this answer to 5 meters. Lastly, when t equals to 0, s equals to 4, so once again the particle starts off 4 meters away from our fixed point of O, and when t equals to 3, s equals to negative 5 meters. Once again, our negative 5 meters is with respect to our fixed point O. Therefore, at the start, our particle is here, so our particle starts off here, and then at t equals to 3, it is negative 5 meters away from our fixed point. Therefore, it will have traveled all the way to this point. And our total distance traveled will be 5 plus 4, so this entire length, which is equals to 9 meters. Now let me reinforce this misconception. When t equals to 3, s equals to negative 5 meters. This shows that the displacement is negative 5 meters from a fixed point O. It does not mean that when t equals to 3, the particle has traveled a total distance of 5 meters. Because as we have proven, our total distance is actually 9 meters. Therefore, you cannot always assume that your displacement is equal to your distance. Using another example, let's say our fixed point O is here. Now let's say at t equals to 3, our particle has traveled a distance of 5 meters away from point O. And at t equals to 6, our particle has traveled the same distance of 5 meters back towards our original fixed point of O. Now your total distance would be equals to 5 plus 5 meters, 10 meters. However, at t equals to 6, your displacement will still be equals to 0 because at t equals to 6, your particle is back at the fixed point. Therefore, there will not be any change in position with respect to your fixed point, and your displacement will be equals to 0. Next, we have velocity. Velocity is represented by the letter v and is the rate of change of displacement s and is given by ds over dt. So this is where some of your differentiation techniques might have to come in. In general, if a particle has velocity v, when v equals to 0, the particle will move in the direction of the positive s-axis. So this is when v is more than 0. If the particle moves in the direction of the negative s-axis, v will be less than 0. And v equals to 0 when the particle is stationary or instantaneously at rest. Instantaneously at rest occurs when the particle changes direction. When t equals to 0, v equals to 0. This means that the particle starts off stationary at this point. From between t equals to 0 and t equals to 3, v, the velocity, is equivalent to 3 meters per second. So this means that the particle is moving in the direction of the positive s-axis, therefore in this direction. Afterwards, when t equals to 3, v equals to 0. So this v equals to 0 means that the particle is instantaneously at rest, which means at t equals to 3, the particle is changing directions. So therefore, at this point, v equals to 0, and you'll see that the particle later changes directions. So from when t is between 3 and 5, your velocity v equals to negative 4 meters per second. Since it's negative, it means that the particle is moving in the negative direction of the s-axis. So in the opposite direction as at the start. That's why these blue arrows here is the general path of the particle. Next, we have acceleration. So acceleration is represented by the letter A. It's the rate of change of velocity, which is your v, and is given by dv over dt, or d2s over dt square, whereby your s represents your displacement. So basically differentiating your displacement 2 times. So this acceleration has a similar concept of when you're driving on the road and your vehicle picks up speed or slows down. So if a is more than 0, the particle is speeding up or is accelerating. If a equals to 0, the particle moves at a constant speed. It is a misconception to assume that when a equals to 0, the particle is not moving at all. Some people might fall into that trap. If a equals to 0, it simply means that the particle has maybe a constant speed of 5 km per hour. And finally, if a is less than 0, the particle is slowing down or decelerating. So if an object's acceleration is -2 meters per second square, we will say that it is retarding or decelerating at 2 meters per second square. So since you've mentioned that it's already decelerating, we've already put across the idea that it is slowing down. Therefore, we don't have to add the negative sign in front anymore. We will now move on to some examples. A particle P travels in a straight line so that t seconds after passing a fixed point O, its displacement, s meters, is given by this equation. Find the initial displacement of P. So whenever you see the word initial always tells you that t is equals to 0 because your time hasn't started yet. Therefore, it's initial. So you will simply sub t equals to 0 into your equation, your given equation of s, to get a -3 meters. This tells you that the particle starts off 3 meters behind point O. So let's say here is point O. Your particle starts off here, whereby this is 3 meters. Part 2, the value of s when t equals to 2. Simple enough, you basically sub t equals to 2 into your given s equation again to get your -1 meters. So this means that after 2 seconds, your particle is now only 1 meters behind point O. So about here, whereby here is your 1 meter. Therefore, it shows that the particle has traveled 2 meters towards point O. And lastly, find the total distance traveled by particle P during the first 2 seconds. So as drawn out previously, you'll see that the particle started off 3 meters away from point O, and after 2 seconds ended up 1 meters away from point O. Therefore, we can conclude that it has traveled a total of 3 minus 1 meters, so 2 meters. And if you ever face any difficulties finding the distance traveled, always draw out the particle path to help you visualize it. Next, a cyclist starts from a point A and travels in a straight line. His velocity at time t seconds after passing A is given by this equation. Find firstly the initial velocity. Once again, when you spot the word initial, they're basically telling you to use t equals to 0. Therefore, you just sub t equals to 0 into your v equation, which will give you 0 meters per second. Secondly, the values of t when the cyclist is instantaneously at rest. Now, recalling from the previous concept, instantaneously at rest means that v equals to 0. Therefore, you will equate your v equation to 0. So you factorize out your t, and you'll get two equations. T equals to 0, or 3 minus 1/4 t equals to 0. Therefore, your answers will be t equals to 0 seconds, or t equals to 12 seconds. And your 12 seconds is derived from this equation. So moving the 1/4 t over and multiplying both sides by 4. It is good to note here that it means that the cyclist is making a turn at t equals to 12, because that's when it's instantaneously at rest, which means that the cyclist is changing directions. Finally, using the value of velocity when t equals to 13, explain the motion of the cyclist from t equals to 0 to t equals to 13. So firstly, we will sub in our t equals to 13, and we'll get a velocity of -3.25 meters per second. This means that the cyclist is cycling at a speed of 3.25 meters per second, but at the negative direction. So if we draw it out, we have our path starting from point A. So this is where t equals to 0. And then the cyclist will start traveling in this positive S direction. Afterwards, it makes a turn at t equals to 12, and it will start traveling back towards point A with a speed of 3.25 meters per second. So in this direction. Therefore, it is back towards the point where he had started from. In this case, it is point A. Therefore, your answer will be the cyclist started at rest at let's replace this with point A and cycle in the positive direction before making a turn at t equals to 12. He is now cycling towards A with speed of 3.25 meters per second.